Sir, we are group number 8, Digital Twin for EV Battery Management. We are doing real-time RUL prediction with LSTM and cloud integration. Here, this is the system architecture. So first, we have a dataset. The dataset we are uploading to the GitHub, and using HTTPS, we are calling it into the Arduino R4, and we are using MQTT, and we are sending the data into the HiveMQ thing. So let's see the code for the particular architecture. So here we can see I have connected this Arduino. I have connected this Arduino to my system, and this is a code. So here we can see, like, I have entered the GitHub CSV details. I have uploaded the data in the CSV in this GitHub. So I am using that, and I am streaming, and I am after that I am also sending it to the HiveMQ Cloud MQTT broker. Let me run the code. Yeah, so we can see the Wi-Fi has been connected, and we are connecting to the HiveMQ MQTT broker. So here we can see the data has been transferred from the Arduino Uno, and it is being published to the MQTT. And here in this laptop we have this MQTT. Here we can see in this HiveMQ cloud, the data has been the published data has been, we can see the published data over here. So our next task is to train a machine learning model. For our training of our machine learning model, we have considered the data. We have considered as we are using the LSTM. So here this is a time series data. We are using it for RUL, remaining use lifetime prediction. So we have chosen time series models such as LSTM, BiLSTM, GRU, and residual blocks, and we have trained the model with the data, and at the last we have obtained some results. So we have noted those results in this particular presentation. Here we can see this LSTM is having less MAE and less comparable RMSE value, which is best for our thing. So we have trained our LSTM model, and we have stored the model in the PKL format. And once we have stored the model in the PKL format, now we have already pre-trained model, and we have some data from HiveMQ. So now we are subscribing to this HiveMQ data, and we are sending the data to. Now here we can able to see, like, we have used the MQTT. So initially we have published the data. Now we are subscribing to the data, and we are running this RUL model which we have saved, and we are getting some prediction. That prediction we are sending it to the Firebase, and we are storing so that we can get it in the real time. Here we can able to see the data transfer of see, all the variables have been transferred from the local thing, and also so here we can see the data has been stored, as well as our RUL prediction is also being stored. And here for our RUL prediction we are taking 30 records. So here we can see that now we are subscribing to the data from MQTT, and we are publishing the data along with the prediction to the Firebase. Here we can see the real-time updation. Just a second. So here we can see the data has been published, like the data is subscribed from the MQTT as well as subscribed to the Firebase along with the prediction. Here we can see that the things were getting updated in the real time. So basically, until now we have created using MQTT. We have sent it to the Python plus LSTM model, RUL model, and we are uploading it to the Firebase real-time database, and we are having a 3D dashboard visualization which we have done in Streamlit. So the real-time data has been updated over here. Here you can see it's collecting data, and the data is also being updated. And after first 30 records, we will be getting the RUL prediction, because we are training the LSTM model. It works on a different uh, sequence of data, 30 sequence of data. Here we can able to see the real-time gauss, which will be updated, and we can also see the historical trends, how the RUL has been predicted and the state of charge has been done. And if the RUL is low, we will be getting some warnings here. These were the warnings of the previous run. So just a second. So here you can see, after the transfer of these 30 data, we could able to predict the RUL. Here 10.49 cycles means like you can use the battery for 10 cycles like that, and the RUL will be updated. Here we can able to see in the real-time dashboard the health status is a bit good, and the speed, these all things will be updated. See, like for every 5 seconds we will be updating these all stuff, and based upon these metrics and different metrics, the RUL will be predicted. So here we can see the historical trends as well as the RUL prediction. For every 5 seconds we will be updating this data, and the updated RUL will be detected. Thank you. This is our project.